Welcome back to Daily LeetCode Day 96. We are back once again. Yesterday, I promised we would do the weekly challenge. I promised we would do the weekly contest. I think it was 311, but it didn't start while we were doing it, which was tough because we have like a predefined time we try to stick to. But you might also notice that I'm wearing the same shirt I was wearing yesterday. It is what it is. I actually wear the same shirt every day. So, a necessary evil. Maybe tomorrow wear a different shirt, but it is what it is. I don't know if we'll do weekly contests today. I don't know if I'm in the right headspace. We're doing an hour again. So, we're back to doing an hour. Since we're back to doing an hour, we're back to doing an hour. We're back to doing an hour, so maybe we should do it. It's tough to say. I kind of just want to keep. keep doing easies. Maybe the easies is killing the channel. This may actually be true, but it's just a lot of brain power being expended. If I use all my brain power on mediums, then I think it takes away brain power from other stuff. But I also read a book, and I remember reading a part in a book, and they mentioned that I think they were like given children, and they were working on I don't know, maybe it was children or adults, but they were working on tasks, and if the child or the person had the mindset that how much they could, I remember now, it was from the book called the Marshmallow Test. And it was basically there were two models of thought. And the first model was, I have enough self-control and I always have enough self-control. And the second model was, I have a finite amount of self-control and once I run out, I can't control it. And they found that neither model was necessarily true. It really depended on which one you believed in. So if you believe that you had a finite amount of self-control, and then once you ran out or used it up, then you couldn't do it anymore. You couldn't control yourself anymore. If you thought that you had infinite self-control, right? No matter how much you had already controlled yourself, you could always control yourself more, right? Like if you're like, let's just say did LeetCode for 9 hours, and then you go on a binge of something else, right? They were saying that depending on how you thought, even after you did LeetCode for 9 hours, you could still control yourself if you believe that was the case. That being said, I remember reading the book or that passage and thinking, I'm definitely in the second bucket. I definitely think it's a resource. I think it's definitely a resource, but I think like the passage was saying, there's no definite answer. It's really which one you believe in, and I definitely believe in the second one. That being the case, since we believe in the second one, there's definitely a resource bar, and the resource bar version is what works for me, unfortunately. So the resource bar mindset is kind of how we got here. So there's only two ways that I've been able to think about it. It's either you reduce how much effort the task takes, or you learn to increase the capacity. So if you use a car analogy, if you wanted a car to be able to go further, right, there's only two vectors for optimization. Either you can change the engines or optimize the engine so that you take less gas to travel the same distance, or you can increase the capacity of the tank to hold more gas. The one that I usually opt for is to optimize the engine or reduce the load, basically. So I usually reduce the load, but I think, I guess it's a bit of a balancing act. Try to reduce the load while lengthening or increasing the capacity of the car. But I just find an increasing, maybe this is just part of the working at something where there's always going to be a little bit of a stump. But the recovery run that we've been doing, I have to be honest, has been very helpful. So we've just been taking it a bit easier. Still doing it every day, but just taking it a bit easier, which, as I'm going to be honest, has really helped. So now I think we're still taking it easy, but we're trying to take it easy for longer. So like around an hour of easy problems, which is, definitely not high octane LeetCode Code Forces 2800 level, unfortunately, but yeah, just trying to stay in the game. So I think since we're moving back to doing an hour, I think we'll eventually get back there. I suspect we will be back to mediums in 2 months. 2 months, I suspect, just because I'm trying to learn a bunch of other stuff, and I have to be honest. I think LeetCode gives one like an aspect of mental fitness, like not mental like in general, but like mental, I guess like programming fitness to some respect. And so I think it's easier to, I think, break down things, since you have to like understand all these patterns and like constantly being exposing yourself to new like problems and patterns, right, and ways of structuring requirements, asking questions, asking clarifying questions. And there's a programming fitness there. But also, if we use another analogy, right, if you were going to be, an Olympic runner or doing some, really like hardcore sport, to some degree, all sports have some like requirement for fitness, even like acrobatics, right? Like the people in those sports are like crazily fit. So even though they are fit in that way, they still have to do like domain specific like work. So they still have to do their routines, their acrobatics, their stretches, their routines, so that they can actually be performing in their thing. I think there's an aspect to LeetCode where it can be like a rabbit hole, where you have a lot of programming fitness in one aspect, but like for example, when I started this challenge, I couldn't even create a back-end application, but I was working on these problems, and I think maybe that's like I couldn't create a back-end application, might be too strong, but I guess what I'm saying is I think sometimes it can be a rabbit hole. So I don't want to get too stuck on just LeetCode, because at the end, LeetCode is a tool for getting better, like the fitness aspect, which should make learning other things a little bit simpler to some degree. So yeah, I guess I'm just roundabout way of saying the LeetCode aspect is important, but yeah, trying to stay doing the other stuff. So I'm taking some courses outside of LeetCode, like on some programming websites, to stay to keep learning. So with the LeetCode, I also end up doing some other stuff. So yeah, it's just kind of tough to also do hardcore LeetCode, mediums and hards, and then go into the other courses. So all this to say, the grind continues, but I feel bad. I think, the weekly, I felt good at the time, but rip, man. I think we'll have to return. Maybe it'll be like a One Piece thing where, we do cross out 3 days, and we put in 2 years. So we're going to be doing easies for a while, likely. But when we come out, will be a problem, because I think mediums are usually a combination of concepts from easies. So maybe we'll start frying mediums. After we do all the easies, there'll be no choice but to always do mediums, and then there'll be hards. Ultimately, the goal is to finish all the problems, so we'll get there. So I'm just going to jump into it. I'm going to restart my timer, and we're going to do 1 hour. So let's just jump into it. Let me shrink my camera. Also, don't forget to join the Hyperbolic Coding Chamber. This is a legendary coding chamber. There are thousands and thousands of people joining every single day, so you're going to want to join to get up to date on the secret tips and tricks in the LeetCode community. So I'm just going to jump into contains. We're just going to do more of them. I think we did remove linked list elements. Trapping rainwater, that was a fun problem. I remember doing that one. That's a good hard problem. So you have contains duplicate set up, and then we have implement stack using queues, and then we have summary ranges. So let's see if we can do those today. So we have an hour. So let's just jump into if contains duplicate. So given an integer array nums and an integer k, return true if there are two distinct indices I and j in the array such that num sub I equals num sub j and the absolute value of the indexes is less than or equal to k. So we're given an array of nums, integer k, return true if there are two distinct indices I and j such that their values are the same, but the absolute value of their difference is less than k, which is an interesting requirement. But we have 1 and 1, which means there's a duplicate. We have 1 and 1, which means there's a duplicate. It's interesting. So we're saying num sub I and num sub j are the same, and the absolute value of I and j is less than or equal to k. So here we have an array, right? And we know that there are two distinct indices, 0 and 0, 1, 2, 3, right? Such that their values are the same and the absolute value of their indices, 0 and 0, 1, 2, 3, 3 minus 0 is less than or equal to k. So then here we have k equals 1. And I'm looking for two values such that their values are the same. So we have 1 and 1, right? 1 and 1. And absolute value of the difference is less than or equal to 1. So 0 minus 1, 2. So 1, 0, 1, 2. So this is indexes would be 0 and 2. 2 minus 0 gives you 2. 2 is not less than or equal to 1. So what are they using then? Maybe they're using this 1 and this 1. So you have 1 and 1, right there. The values are the same, and 2, right, minus 3 gives you 1, the absolute value, which is 1, which is less than or equal to k, which is 1. So right now I'm thinking of an n squared algorithm. Thinking of an n squared algo that just checks if this property is true for every element, basically. And so I have to return true. Num's length has a minimum of 1. Which means that contains duplicate has a potential to be false because you need at least two distinct indices to return true. So for if the array length is 1, we can just return false, but we won't add that for now. K can equal 0. So okay, I think we could do this. I'm imagining an algorithm where we do an n squared iteration where we'll start at 1, right? And then for every value that's not 1, right, we'll check, right, if this statement up here is true. Are the values the same? And is the absolute value of their indices less than or equal to k? Right, and I think on this first iteration here, we'd find that this would be true. Can we have one where that wouldn't work? I think we would be fine. So n squared I think there's a linear time version of this as well, but we'll do this version for now just to make sure that we can make it make sense. There's no follow-up. So n squared algo. So what I'm thinking is iterate through nums. Iterate through nums again. Check if both cons. I think there's multiple. I think there's 3. The values are the same. Yeah, the values are the same. Abs. Right. Okay. Check if all 3 cons true. Right, and at the end we can return false if we never find one that allows that to be. If we never find an instance where this is true. So to iterate through the numbers, we'll say 0, right, going up to nums.length.each. We'll have an outer for loop, which we will copy, and then we'll do the same, except we're going to want to start at outer itself and then go up to nums.length. Right, and then we're going to want to check if all 3 cons are true. 3 conditions are if the indices, right, so we have an outer for loop and an inner for loop. And we're actually going to want to do outer plus 1. And this is so that if we're iterating, right, an n squared algorithm, if we start at 1, we don't want our inner to also start at 1. We want it to start at 2. And then we'll stop it. We'll bound it to be nums.length minus 1 so that we don't go out of bounds. And I think we should be good. The first condition is that the indices are distinct. So if outer is not equal inner. The second one is that the values are the same. So nums sub outer equals nums sub inner. And the third condition is that the absolute value of the difference is less than or equal to k. So to do that, we'll say outer minus inner dot abs is less than or equal to k. Right, if that's the case, we're going to want to return true. Now let's see if this makes sense. We're gonna have nums array, right? 0 dot 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 nums dot length minus 1. So we're gonna go from 0 up to index 3. Right, outer is gonna start at index 0. Outer plus 1, right? So we're starting at 1, going to the last element. So we don't want to bound this. Each do inner. So we have outer and inner. Indices 1 does not equal 2. So we're gonna go to the next one. 1 does not equal 3. Oh no, 1 does not equal 2, so that's good, but the values aren't the same. So we go to the next one. Outer does not equal inner, which is good, but num sub outer, which is 1, does not equal num sub inner, which is 3. Then we go to 1 and 1. The indices aren't the same. The values at the indices are the same, and 0 minus 3 is less than or equal to k. Let's see if this works. This works for the first case. Let's try the other cases. Oh, so you can't do n squared. So n squared is too slow. So I see. So right now this is n squared. I think we could do better if we sorted. which would bound us at n log n, which is already better than n squared. Now, if we sorted it right, we would get 1, 1, 2, 3. Right? And then all we have to do is just check the current element and the next element, right? So we'd say 1, 0 does not equals. The problem would be that we'd change the indices. Does changing the indices matter? Yes, I think it does, because if you look at example 2, the only one that actually works is this one here and this one at the end. If we were to sort this, let's just say that this one here was missing, we would return, the new answer would now be false, but if we sorted it, we'd actually get true. I think we could still do this. What if we changed our style completely? Instead of sorting, we switch to a map approach. We switch to a map approach, right? Our map could look something like this, right? For the number 1, right, we have these indices, 0 and 1. For the number 2, we have these indices, 1. Right? For number 3, we have these indices, 2. Right? And then it would take us linear time to create a map, and then we would just iterate through the map again. Or now we could iterate through the map, which at worst would take linear time if every value is distinct. And then all we'd have to do is check all we have to do is check that in the array, if we can find 2 values such that the absolute value of their difference is less than or equal to k. Num sub I is equal to num sub j. Let's try this maps version. I'm curious on the time complexity, which is why I was silent, but we turn it into a map. We take linear time and turn it into a map. But then if we wanted to check if these indices meet the case, it would just be linear time. I feel like numbers can also be negative. Oh, let's think about the worst case. The array is all ones. B2. I feel like this is the same time complexity. I feel like I get the vibe that it's the same time complexity. There are two distinct indices I and j in the array set. Num sub I is equal to num sub j, and ab sub I minus j is less than or equal to k. Now you have not n squared. Could we get to n log n? What if we have the array? So you have a map potential solution. Could do something with sorting. What if we did D and Q, divide and conquer, or D and C? We have the map solution seems like n squared. Sorting, the problem is we lose track of the indices. No, I think the map version is actually, worst case, is some constant. Worst case, I feel like the map solution is the right way to go, but I really worry about the time complexity. I think worst case it's n squared, but I think average case it's better. Maybe we'll still pass. That being the case, we need to load these values into map, or we'll say hash.new. The default value is going to be an empty array, because you want to map a number to its indices, right? So if that's the case, I think we can do nums each do, and if you can get the index and the value. We'll see though. And then we'll say puts v end, and I'm just curious if you can do that. I don't know what the output here is. We have I and V. Let's just do a regular iteration. We'll just say starting from 0 and going up until nums length id egg. Right, we want to say hash sub num sub idx dot push idx, and then we can put hash afterwards. Oh, I see. We're using the example test cases. I think we could have did what we did before. Say nums dot each do say the value, then we want to push the id egg. I don't remember my array is empty. So you can't do what I did before. Okay. some reason my Vim bindings are messing up bad today. Do puts hash. Now we have an empty hash for some reason. Then the default value should be an empty array. Let's push nums sub idx. So what is going on here, nums? I'm so confused as to what's going on. I have a hash, I'm giving it an empty array as a default value for looking up a key. Doing hash sub num sub idx. Should be an array dot push. When I do hash dot each do kv, we get nothing. So I guess we'll say if hash then we'll do what's happening here. Otherwise we'll do hash sub nums sub idx equals an array with idx in it. I think it exists. Method I was looking for is key. So this seems to load the hash with what we're looking for. Can I just do puts hash now? Okay, so now that seems to work. Yeah. So now we can just keep what we had. And then the goal will be to pretty much iterate over this key value pair. The key is the number and the value is an array of the value is the array of the indices. And so there are three conditions, right? The indices have to be different. And v sub idx minus v sub idx plus 1 dot abs less than or equal to k. And we don't have to check the case where the values are the same because the hash already does that for us. always should have to check for, right, we're going from 0 up to v.length minus 1. And for each index in this array, we're going to check that the index values are not the same, and v sub idx, the difference of the indices is less than or equal to k. So missing an and. So we'll put, for some reason we're returning false still. We're going to put v to see what we're dealing with here. Okay, it looks like we may have got values mixed up. Do puts k instead. Yeah, I'm very confused. So let's check. I'm gonna say k is this, and v is this. So it's definitely sorted. Let me iterate for each index in V. Start at 0. 0 goes up to 2 minus 1, which is 1. While it's less than 1, the V sub idx, which is 0, does not equal Vi sub idx plus 1, which is 3. And V sub idx minus V sub idx plus 1 gives you negative 3. Take the absolute value, which is less than or equal to 3, so we should return true. We don't. So I'm just going to put V sub idx, V sub idx plus 1 to see why that is. Okay, so we're iterating through this correctly. I'm gonna print v sub idx does not equal v sub idx plus 1. Should be true. And then I'm going to print v sub idx minus v sub idx plus 1 dot abs is 3, which is less than or equal to k. My output is still false. Huh? V sub idx minus V sub idx plus 1 dot absolute value is less than. I guess I'll just check. I'll just say less than or equal to k. Wait, 3 is less than or equal to 3 though. Wait, I'm so confused. For some reason, up here when I do... Okay, we're just gonna call it abs v sub idx minus v sub idx plus 1. I'm gonna put abs. I'm gonna say abs less than or equal to k. Oops, I forgot to do the absolute value. So abs is literally 3. When I do abs is less than or equal to k, it's false. What is going on? This is so strange. I'm getting 3 here, but somehow 3, which is here, for some reason 3 is not less than or equal to 3. There must be something I'm doing. I must be overlooking something. Wait, how is 3 not less than or equal to 3? But when I do it for k, maybe we just need to put k as well. Wait, but it says k is 3 here. I'm so confused. I'm so very much confused. Oh my god. We have a shadowing problem. K means oh man. K means key here because of K and V. Oh man, this is bad. So we'll put this back to v.sort. In fact, we're not even using k, so it doesn't even make sense to include it. Ah, that's a major yikes. Shadowing is crazy, man. I don't think this works without sorting. Apparently it does. I can't believe this took us 40 minutes. I think it was the KV thing really got me messed up. The shadowing really messed me up. But you live and you learn. I'm thinking the space, worst case in the hash, will take up to n numbers, n keys, assuming all the numbers in the array are distinct. And then if we were to use the hash, or we're iterating through the hash now, doing a linear operation, it should be another Actually, I think this is n log n. Even if you sort, it's n log n. But if you don't sort, I'm pretty sure this is linear time now that I'm thinking about it. Because imagine we'll map, for example, if we had an array, right, that had 100 items, each were 3 numbers, 1, 2, 3, and 4, and there are 25 of each, total 100 numbers. The first pass we do with creating the hash, we'd have 4 indices in the hash, or 4 keys, 1, 2, 3, 4, with 25 elements each. Then we do a linear time iteration through each, which would mean we traverse the whole array again. And the worst case, assuming that our value is in the last key, we'll have iterated over the entire array again, which would be 2n. Now, if you were to sort the subarray each time, you'd ultimately end up getting n plus n log n. Because by sorting each smaller piece, it's almost like sorting the entire array. So since you can do this without sorting, I think this would be linear time. Wait, huh? Did we over... Wait, this doesn't make any sense. Algorithm is the same as... Wait, did we overcomplicate this? It says contains duplicate. I think the part where they messed me up was they said and absolute value of I minus j is less than or equal to k. Like, that's just a strange requirement. And then it actually... I think that's why I had so many downvotes. Let me see. Wait, they're talking about two-sum? Maybe this question, I think this question changed because the function is called contains nearby duplicate, but the problem is called contains duplicate. I guess the inclusion of a case where we have to say absolute value of the indices is less than or equal to k is a really strange requirement. is less than nums.length, so they're iterating through. Take the max of I or k. Keep a sliding window of k elements using self-balancing binary search tree. Yeah, this is very strange. I don't really understand what this question is asking. Or maybe this is one of those questions where I don't understand. I don't really understand. The question seemed like it was asking something completely different. The solutions. Or they're not really explaining why we need this case. The absolute value of I minus j is less than or equal to k. Is another way of saying what exactly? You know what? Maybe it doesn't matter. We're just going to continue. We have implement a stack using queues. Implement a last in, first out stack using only 2 queues. Implement a last in, first out stack using only 2 queues. Implemented stack should support all the functions of a normal stack: push, top, pop, and empty. Implement the myStack class. This is element X onto the top of the stack. In pop moves the element on top of the stack and returns it. Top returns the element on top of the stack. Turns true if the stack is empty, false otherwise. You can only use standard operations of a queue, which means that only push to back, peek / pop from front, size, and is empty operations are valid. Depending on your language, the queue may not be supported natively. You may simulate a queue using a list or deck, a blended queue. As long as you only use a queue. So you can only add to the front and remove from the end, basically. And we have to simulate a stack using using queues. So if they push on 1, push on 2, they take top, it should return 2, pop should return 2, and empty should be false because 1 is still in the stack. Interesting. So I think we could do this with the queue. We have to implement a stack. We can only remove from the front. We can only remove from the front of the queue and add to the end. And a stack is last in, first out. So if we had a queue elements, if we took the first element off the front, first element off the front, the first element off the front I'm thinking of a solution where we can kind of use it like a cup. But a cup works more like a stack does, because anything you add, anything you pour into a cup ends up on top if you subtract the fluid dynamics. So I think we could do a version that would be very, very, very inefficient, but we could use one queue. And I think what I'm thinking of is if we have operations listed here, right, like 1 and 2, right? So you want the stack to be like this, 1, 2. We just call it ands. Our queue is gonna look like this is going to be the internal queue. And I think what we could do, if they push a 1, right? If the queue is empty, we just add the value. We had 1. Now, if the queue isn't empty, to simulate the stack, what we would do, because we can only add an element to the front, we can only add an element to the end, push to back, and peek/pop from front. So what we'd like to do is for the queue to actually, for the answer to look something like this. It doesn't really matter what end, but let's just say that the top is on this side. But our queue looks like this, right? And where we can access from the queue is from this side. So what we could do is when we add 2, what we'll do is, if we're going to add an element to the end, can we guarantee that all elements will be distinct? Even if we can't, we want to add, let's just say 3 onto the top of the stack to get something like this. Let's just say our queue, or let's just say our queue already looks like this. It has 2 at the front and 1. To fix this, right, we can only add values to the end. So we add it to the end, and since our queue had 2 elements before, we actually just pop it from the end. We put 2, hide from the end, and then we put 1. And if we want to add a 4 to the top of the stack, we add a 4 to the end, and then we will just do the same thing we just did. Take 2 and put it here. So I think we can do it with 1 queue. We just make it an array. Then we can delete this and just say at queue equals an empty array. Then we're just gonna fill these in right now just to satisfy. I just want to see if you can do that. Okay, so you can just do it. So the queue is going to start out empty, and we push a value, we'll have basically just 2 cases. If at queue.length equals 0, then just do queue dot. Actually, we can do this. We can say prev length is going to be equal to queue dot at queue dot length, right? And then we're going to say queue dot push x, right? Now, if queue dot length is now greater than 1, right? Now what we want to do is say from 0 up to prev length, pretty much going to perform this many operations. Or we want to say 0 or basically pretty much prev len dot times. We want to do so this many times. We want to do some work, and that work is going to be queue temp equals, or we'll just do it like this. We'll say queue dot push queue unshift. And then when we want to do pop, we can just return the element on top. We'll just say return queue dot at queue dot unshift. Oh no, at queue dot shift takes an element off the front. Unshift adds it to the front. Or which one is it? I think unshift adds it to the front. For top, we can just do at queue sub, or empty. We can just return at queue dot length equals 0. So if we check this for this case and we just ran out of time, we're going to push 1, right? Prev length is going to be 0. We're going to push 1 onto the end of the queue, right? Our queue.length is not greater than 1. Now we're going to push 2, right? So what this looks like is we have 1, right? We want to access from this side. This is going to be the top. And then we're going to say that now we're going to push 2. We're going to say prev length is 1. Prev length is 1. Now we pushed on 2. And then we said prev length times, right? We want to do q dot push, q dot shift. So we take 1 off the front, right? And then we push, take 1 off the front, and we push 1 here. Now we say we want to add 3, right? Prev length is going to be 2. So we do push 3 at the end, and then we say prev length times, which is 2. We're going to do q dot shift, which is 2, and push it here, then 1. So I think this should work. So let's try it. Unexpected. I think we forgot the syntax. So you actually don't even need do. Maybe you do need initialize. So this is pretty bad, but it works. So we end up using push. At worst case, push takes linear time because it takes n minus 1 operations. Pop, top, and empty. And we're assuming that in this case, let's just say we're using a deck, or we're using a queue. So yeah, you can only remove from the front. Since you can, it depends. If you can use an implementation of a queue, like they said with a deck, where you could get pop in constant time, then pop is constant time, top is constant, empty is also constant, but push would be linear time. So it looks like they did the same thing here. I'm curious to see how they did it with the queue, with the 2 queues. Back is LIFO last in, first out, which elements are added and removed from the same end called time. Okay, so when we push an element, we just push it at the end of Q1. So there's linked list. Need to remove element from the top of the stack. see. So we'll stop there, I guess. That is a wrap.